Okay, so morning everyone. Yep. So I Wei Song. You can call me Wilson or Dr. Wen from AE. So this is a brand new lecture, so brand new course. So this is the first time to open this new lecture course. So artificial intelligence for the unmanned autonomous systems. So the US means unmanned autonomous systems. So I'm assistant professor at AE, and also I lead a research lab on the TAS. TAS means the trustworthy autonomous systems. So my keyword is I mean generally I work in quite a lot of topics related to the unmanned autonomous systems. So quickly go through my biography. So my keywords, as I just mentioned, my keyword is unmanned autonomous systems. I working a lot on the drones and on the self-driving cars, and also leverage the technologies from the artificial intelligence for the drones and also for the self-driving cars. Any of you have taken my course before? AAE4004? No? Any from year four? No? Year three, right? Okay, so I mean, in short, my keywords is unmanned autonomous systems. If you are interested in my research on artificial intelligence and drones means unmanned aerial vehicles and self-driving cars. So feel free to drop email to me or drop in my office. So, for example, I active in the societies including the ION and the Robotics Society and this is Intelligent Transportation Societies. And also, so all those societies are belongs to the AAE. Okay, AAE. And in terms of research collaborations, we have quite a few industries. So, for example, if you want to secure some internships, also I can help if you wish. So roughly, it's about my keywords. Okay. So for this new course, so what you so generally what you expect is you want to learn something about artificial intelligence, right? Because currently is I mean the world is changing, so especially in the past 4 to 5 years, so everything is changed every day. So we have ChatGPT and also we have a large language model and even so for example yesterday I received a look into the latest paper. So one for the paper says, so the large language model can, I mean, even be implemented in the laptop level. Okay, you don't need to have a workstation to run a large language model. It means we are getting to a new period. It means this is the edge computing. It means any of your edge size devices like your smartphones can even run a large language model. Okay, it's getting smaller and more close to our daily life, even our daily research. So this means a lot of research is not going to be meaningful. So because you have the large language models, a lot of physical models we have learned from the high school or maybe from your core subjects may becomes not that important because the large language model can do a lot of things. So as I just mentioned, what you expect from this course is you want to learn because this is a lecture course. So it means you can learn a lot of things about the artificial intelligence and a lot of practicals, and hopefully you have some hands-on projects related to the coding with Python. So any of you have taken a course related to the Python or like okay, two ways. The first way is that you have taken the courses related to Python, and second way is you have do some projects related to Python. So hands up, one, two, three. Any more? You? What about you? Python? No? No before? Okay, so yeah, later you are going to look into my teaching plan. So this week is about fundamentals. So have a good sense of what going to be delivered and what going to learn from this course because you are going to have the agile period, right? So the second lecture is going to be the fundamentals for Python. So we are going to provide some examples to have some hands-on practice for the Python programming. So in terms of the teaching assistant, okay, we have a team. Okay, we have a team working on this electric course. So, for example, like Ziqi, Yang Qian, Wang Xin, Shao Ting, and Ren Zhi, so they are all PhD students or research assistant in your lab. So they are going to help with us on because majority of them have the expertise in Python or either in Python or in artificial intelligence. So the features of TA and the role is helper in the lab session. So in this course, actually we requires a lot on the programming. Requires a lot on the programming because like so later I'm going to introduce the ChatGPT for you. I think if you want to learn artificial intelligence, so instead of writing reports, the ChatGPT is one of the best tools to help you. So for example, like if you use a ChatGPT to write a report, so you're not going to learn what is innovation. So if you, I mean, seek help from the ChatGPT to help you to provide basic code, I mean, in Python, it can be great. Then you can learn from the code generated from ChatGPT and change, make revisions to satisfy your requirements. So second one is actually they are experts, as I just mentioned, they are experts in either in AI or coding with Python. Okay, and also majority of them are working on the UAS. Okay, UAS means Unmanned Autonomous Systems. So this includes the drones and self-driving cars. So this is roughly the roles of those TAs. So for each year, I suggest we make some okay cross communications. Like okay, for example, a self introduction about yourself because we only have like in this course, I think we have 15 or 14 students in this course. I think we have some time to make a brief introduction for yourself. So okay, let's do this. You get make a brief introduction for yourself and any U4? No, no U4. Right? So it means you don't have the final year project. And let me know your expectation. So why you select this course? Because I wish to collect, I mean, your expectations for this course. Okay, so Reese, start from you. Okay, make a brief introduction about you and why you select this course. Yeah.
So I select this course because I'm working with GNSS, and a lot of people around me are working with things like SLAM, and I no, but I want to learn about it. Yeah, I want to learn something from this course. Yeah.
Hello, works. Hello, I'm Sahat, and I'm in year three, and I selected this course because I'm working in machine learning in GNSS, so it's quite similar to this one. And last semester I took guidance and navigation, and it was quite interesting, and it's quite similar to that course. So yeah, that's why I chose this course. I expect to learn some new techniques or some to get some ideas on how I can integrate ML with uh, navigation systems and all. Yeah, I think the tools. Yeah, 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 and also algorithms as well. Yeah, thank you.
So because as you know, the university encourages each of the course to have the flipped classroom. It means each of our students are encouraged to be included in the course. So especially for this course, it's a small size course. We have a lot of time and we have, yeah, we can have. I see. I try to have more increment of you guys in this course, especially for the lab session and in the later weeks we have the group presentations. Yeah, later on. Okay, so Yang Qian, so briefly introduce yourself. So this, so she is your TA, and she's working on those fundamentals of drones. Briefly introduce yourself.
Hi, I'm Yang Qian. I'm the teacher assistant of this course, and now I'm working on design a UAV platform for our team.
So Yang Qian is I mean she graduated in like 2024 something, and she's been PolyU for around 1 year to working on drones. Yeah.
I'm Ken from year 3 student, and also year 3 AE, and a member of team from a team member of DBF team in PolyU, and in this is a team for joining a competition. DBF is stand for design, build and fly. It is a competition for you design a whole aircraft, a fixed wing aircraft. Yeah. Fixed wing. Yeah. And each year the competition is required to build a new aircraft for that specific competition and mission. And in this course, I want to learn some techniques from the AI and try to implement them into my yeah. Yeah.
From more like practical side, for
Yeah.
example, like so yeah. I mean, a lot of things can be learned from this course. At least you can learn those detection. For example, YOLO, you only look
Yeah.
once, so those networks can be applied for the detection for drones. A lot
Yeah.
of things can be applied.
Yeah. Also, the design thinking of the aircraft structure. Yeah.
Design. Yeah. I cannot cover too much, quite a lot.
Yeah. I try. Yeah.
You want
It's
to learn design, you want to learn AI, you want to learn the slang.
yeah. The design is okay. Yeah. In the design, I'm okay with that, but just try to implement the AI to help me to get some value of that structure to elaborate the structure. Yeah.
Also, you can see one thing is like actually for the structure design. So originally this is quite related to the guy from mechanical engineering.
Yeah.
But currently we have an AI. So I think the story is going to change. You can think about how the AI can help you with the design.
Yeah.
Because currently especially for a ChatGPT, you have learned aerodynamics, right? The ChatGPT has learned all the books, electronic books available in the society, in this world. ChatGPT has learned everything. But the problem is like you learn the same books. For example, okay, I give you the same books. Some student can go to PolyU, some student can go to USD, and some student can go to MIT. So why? Because they have different learning capabilities, and the quality of the books. The quality of the books may be different. Means the classroom teaching may be different. So the next milestone of the ChatGPT currently is how to guarantee the quality of the data to accelerate the learning efficiency and accuracy of ChatGPT. You see, the next milestone is to how to guarantee how to get the basic quality of the data. Yeah, that's what you can try to see if there are some opportunities to make use of the ChatGPT or some large model to help you to design of the structures of the aircraft. Yeah. Thank you. So brief introduction. Brief introduction about yourself and your name, and brief introduction about yourself. Are you 3 or you 4?
Year 3.
Year 3. And let us know what you expect from this course. Roughly, what you expect. For example, they say they expect to learn something about artificial intelligence, and they want to learn something about slang. So what you expect? Brief introduction first.
So my name is Anson. I'm a year 3 AE student. And why I select this course because I want to learn knowledge about the interaction of AI and unmanned aircraft in here. So yeah. No.
Personally, you want to learn how to interact with US and artificial intelligence.
Yeah.
Thank you. Thank you. For you?
My name is Emil, and my name is Emil. Yeah, and I'm a year 3 AE student, and I selected this course because I'm a little bit be interested in UAS, and I want to learn more knowledge and skill about AI, UAS, also Python coding.
Oh, you want to learn. Have you learned the Python before or
A little bit.
a little bit, but you want to learn more, right?
Yeah, yeah, yeah.
Okay, I see. Thank you. Thank you. So, yeah. For you.
Hello. My name is Fei Yao, and I am a exchange student from NPU. So my English is maybe not very good. And I choose this subject to practice my
Oh, you are the final year. You are like you.
yes.
Okay, final year. So
To
what is your final year project title?
my project title is Satellite Navigation for Urban Air Mobility. Dr. Yiping Jiang. And I think maybe learn this subject can practice my skills and let me do my work well. Yes, a little. Yes. No. But yeah.
Hello, I'm He Yifan, and I'm also an exchange student from NPU. And my final year project is path planning and path planning for collaborative multiple UAV areas exploration. Dr. Huang Hailong. Yes. Maybe some basics. Yes. Okay. Thank you.
My name is Zhang Yifan, and I'm from Northwestern Polytechnical University. Yeah, yeah. And I'm majoring in energy and power engineering. And my final year project is relative virtual localization for unmanned aerial vehicles. So I select this course, but my teacher say it's just a little help for me. And the Dr. Wang Bin. And I cannot understand clear. And my and this is the first experience for me to participate in the class with English actually. So this is a big challenge for me. And thanks.
So,
My name is Qiu Xiaoting, and I'm also the TA of this class. My my research mainly focus on HD map and spoofing of UAVs. And if you have any questions, you can ask me. Okay, thank you.
okay. So Shaoting is quite expert in Python. So I mean, she's graduate from undergraduate from universities. Is one for a based university in mainland China, working on the computer science. Okay, so let's move on for our lecture. So always I emphasize, okay, you should be open mind, speak English, and participate activities assigned and ask questions. So, and for teachers, of course, I will arrive on time, reply emails on time, and answer questions related to the subject. So be curious, be inspired, and motivated. So one more thing I want to emphasize, study further by yourself, because yeah, I spent a lot of time to design a lecture, but still I still have every day I would say every week I try to revise my slide, because daily I think about how can make the slide to be get you learn more and be more attainable. Attainable means you can learn more based on yourself. For example, provide a link. After this course, I provide some tasks, you can learn more. Because as I just mentioned, currently we have a large model, everything is changed. everything's changed. I mean, you can learn a lot of things by yourself. And what we deliver from this course is like introduce to this society, introduce you to the society about the AI and artificial intelligence. So this is the assessment. So we have two, generally we are going to have two home assignments. So each of you are going to take around like 10%, okay, for each assignment. And we are going to have midterm quiz test, so probably on week 8, and it's going to take like 15%. And a group project, so that's going to be a case study. So 7 members in a group. For example, this is going to be a project related to the AI, and 1 to 2, maybe 2 to 3 members in one group, and each of you need to present, and you need to finish a collaborative, finish a given task. And for the final exam, okay, it's going to be open book. So the final exam is going to be based on all the lecture contents delivered in the course. So the basic requirements, okay, this is required, okay, mathematics on metrics and calculations. So for example, the inverse, transpose, stuffs, okay. Also need to spend extra time for the coding. So at the beginning, I try to design like 2 weeks for Python, but because a lot of content to be delivered, so later I compress the time for the programming. So in this course, currently only 1 week, okay, for the introduction of the Python programming. So sure, yeah, I'm not going to sign attendance, but yeah, encourage you to, because I know this is quite earlier lecture. So basic coding skills with Python. So I expect you roughly have some experiences in Python. So that's why I only provide 1 lecture, okay, for the Python programming. So please, okay, after the course, try to, learn some basics about Python. After the week 2. As I just mentioned, so the university encourages the lecturer, okay, to implement the flipped classroom. Okay, we wish each of you to be included in the teaching, okay, in the teaching. So in here, we design a GitHub page. So any of you have used or know the GitHub before? GitHub? Okay, that's great, that's great, okay. So GitHub is a very good tools for the, oh, what's wrong for this? Oh, I forgot to assign access. Wait a moment. 4203. Yeah. A second. Oh, I need to check with my GitHub mobile, but in this one I don't have GitHub mobile. Let me check. Okay, no worries. So this is GitHub page. So after this course, okay, I will assign access to the public. So any of you can have access to this page. So, but I can share in another laptop. Oh, wait a moment. Sharing. Okay, so this one. So this is GitHub page. So in this GitHub page, you can find a lot of information. For example, later on, the lecture notes will also be available in this GitHub repository, and the code, okay, the Python code examples will also be available here. So also, there is a very important part is the issues. So for example, if you get any questions related to this course or the Python programming, okay, you can try to raise up issues here. Okay, raise the issue here, and OTS will help you to reply the questions. For example, okay, if I raise the issues here, so if you raise these issues and you provide a brief introduction about your questions, so later on OTS will help you to answer the questions. The good thing is this issue will also be shared to other colleagues or other students in this classroom. So for example, A student meets the problem and solved by the TAs, okay, provide solutions here. So the B student, okay, encounter the same problems, okay, you can look into this solution and share this one. So this is a good way to collaborate. So this is one point. Another thing is you can also collaborate on the Python code. For example, if you are working on big projects and they can if they are working on big projects, they can collaborate to finish the coding stuffs. Okay, and in this page, I also provide information about the teaching plan, class schedules, and later on the assignments will be available here. So, and the contest. So this web page, this GitHub page will be updated, okay, every week. So if you are too shy to ask questions in the classroom, okay, you can raise the issues, okay, in this one. You can raise issues in this one, okay, to let us know your questions. Okay, let's go back to the slide. Okay, please take try. Do you have so just now you just mentioned many of you have already tried a GitHub, right? So if you don't have a GitHub, you can register a GitHub account in the break. Okay, later we're going to have 5 minutes break and start this repository. So later on, I will make this repository to be open access. Any of you public available, any of you can start this project. So, and also you can raise issues in the GitHub and learn and collaborate with the GitHub. So any questions about the GitHub? Okay. And also, I always want to encourage you, for example, if you are working on software projects. So if you think your project, for example, do some coding stuff. If you think your coding stuff is very meaningful to the community, you can share this, share code to the GitHub to open source your code. For example, GitHub can be part of your resume. For example, if your repository, okay, you open source to the GitHub, it starts, okay, for example, this is a profile from one of my friends. So the green dots here means he's uploading his code to the GitHub every day. You see, in the past years, almost every day, okay, I'm not sure what happened in the 3 days, right? Almost every day, he uploaded code. And if you snapshot this profile to your CV, okay, it's going to be crazy. So companies will very this one, okay? So for example, some repositories, okay, let me take an example for this one, okay? He gets 3.5 thousands K of the stars from the community. It means a lot of people use the code, okay? This means the impact of the open source repository, okay? So for example, Luis, you just mentioned about Slang, right? So those about LiDAR Slang. This is one for the base repository about LiDAR Slang, okay? And this is for me, okay? So previously I working a lot on the coding stuffs, and especially in the past several years, but recently I have limited time to do this. So you can think about this when you are going to graduate. So how many repositories you have? So for example, for me, I have some repositories like several hundreds of stars, and how many fans you have, and how active you are in the GitHub is, supported by the green dots. So if you upload your code or you be active in the GitHub for 1 day, you get 1 green dots, okay? And if you get 4-page green, it means you are quite active, okay? You are crazily active in the GitHub. So for a teaching plan, So for the first week, okay, it's for today, working on the fundamentals of artificial intelligence. And for the second week, so for each of the week, okay, please take your laptop, okay? Please take your laptop for each of the week, because we have some in-class hands-on practice, okay? For example, do the coding stuffs. And for the third week, it's going to be the introduction of the unmanned autonomous systems like the drones. So from this week, okay, I mean week 3, we are going to deliver a lot of information from the sensors, the power system, the propulsion system, and the electronics, and the hardware, software of the drones. So maybe it will take 1.5 weeks. And for week 4, it's going to be the linear regression. So this is the conventional machine learning. Okay, linear regression and the logic regression from theory to applications. Application means please take your laptop, okay? And from week 5, we are going to talking about the unsupervised learning. So that's mainly about the clustering. So week 4 and week 5 is about the conventional machine learning, okay? And week 6 is about supervised learning. We have the labels. Okay, later we are going to introduce what is labels from theory to the applications. So week 7, we are going to have lab session. So lab session is still in this classroom, okay? Still in this classroom. So take your laptop and you are required to finish your lab report, okay? Lab report means you need to write something about your understanding about the lab session. For example, your understanding and what you achieve and what you have learned and also your thinkings. And week 8, that's going to be a closed-book meeting. Closed-book meeting in the week 8. From week 9, we are going to talking about this is second part, okay, mainly about the supervised learning from theory to applications. So week 10 is about the multi-layer perception and CNN. Okay, so that means convolutional neural networks. And week 11, there's no lectures because this is a holiday, right? You are quite lucky. We get we get 2 holidays, but unluckily we at least need to have a one makeup, okay? One makeup for week 13 because we should have 2 case study. So week 13 is also hard to have a makeup class during the weekends. So later I will collect your availabilities. And we have 2 weeks for the case study, okay? Make a given project and you need to make a slide and make a presentation to all the peers and the lecturers in this classroom. So any questions for a teaching plan? No? So the learning outcomes. So as I just mentioned for this course, the focus is AI, okay? So the platform is unmanned autonomous systems. And it's like 80% for the AI and 20% for the unmanned autonomous systems. We are going to introduce the main components, the frameworks of the unmanned autonomous systems. Okay, for example, we are teaching the general essentials and the propulsion system and some general aerodynamics and also the components. Okay, you can see it includes a lot of things, right? We have different sensors like GPS, camera, and 3D LiDAR. And from software, we have the control, we have navigations, we have path plannings, so for different stuffs, right? And the first learning outcomes is to understand the applications, the core concepts and characteristics and the current state of the AI and unmanned autonomous systems. So usually we call unmanned autonomous systems, it includes the aerial vehicles, okay, I mean the drones, and ground vehicles. Ground vehicles means the civilian cars, and also underwater robots, okay, underwater vehicles. So 3 different levels, 3 different categories. So the second one is the proficiency in using the AI implementations. So for example, we are going to teach you from the fundamentals of the machine learning. So machine learning is the old AI or old machine learning, like the decision trees, the SVM, and the regressions. And tools is very important. As Sahat mentioned, the tools you need to learn the PyTorch because currently we don't need to do everything from scratch. Okay, for example, like everything can directly be implemented based on existing mature tools like the PyTorch or TensorFlow. Okay, you just do some plug and play. Okay, you can just finish your given task. So this is AI-enabled detection for the drones. So it means we are going to provide some hands-on practice. Okay, the mastery of the ability to complete the machine learning. So this is what I expect. This is what I expect. So for example, if you can finish the detection task, okay, based on the euros, so later on I provide some other image, you should be able to do the similar detection tasks, finish the similar detection task. And always, this is really important, okay? So from today, okay, you say, okay, today's lecture is very important, right? You learn AI stuffs. Maybe 10 years later, okay, the course is not meaningful at all because everything is changing very fast. So, for example, I forgot is last week. So one of the universities, um, they decide to get up the lectures about the programming with C double plus. Because in Singapore, for example, like in current changing period, for example, we have the big change in AI, right? But more on the Python. So everything is changed. For example, you may never in 10 years before, they will gear up the C double plus for programming in the undergraduate study. So summarize the change is very important because everything is changed. So for example, for currently we have AIs, right? So like 5 years before, we have the GAN, okay? For example, in the past 2 or 3 years, the transformer, okay, this is core parts of the ChatGPT, the transformer, okay, it becomes very popular, right? So for example, like 3 years before, 3D Gauss, okay, nerf. So those are new different Newtons, okay, emerge almost every day. So especially for those guys doing research on the artificial intelligence, they are very stressful because every day in the archive, a lot of papers. Even for example, Sahat and Royce are working on the GPS, right? If you look into the archive or the Google Scholar, every day a lot of papers, occur in the Google Scholar. If you're looking, just keep track all those updates. You're going to be stressful. And the AI research feed is going to be crazy. Every day it's like thousands of papers, new concepts, new terms, new ideas, new algorithms occur in the Google Scholar. Yeah. So in short, to summarize the change, it means you're going to be dig into the society, read a lot of papers, read a lot of articles. Otherwise, you cannot make a good summary about the change of AIs. So our goal, so this one is quite one of the good examples to show the power of the artificial intelligence. So for this one is based on the deep reinforced learning. So in this course, we are going to also introduce a little bit about the deep reinforced learning. So this is part of the deep learning, okay? So this is outline for today. So take break for 5 minutes, okay? Take break for 5 minutes. So if you don't have a GitHub account, try to get a GitHub account, okay? Based on, you can register a GitHub account based on your Gmail. Okay, so let's move on to the coming slide. Yeah, just now, so we have some latecomers, right? So just now we have make a brief introduction about the. Okay, just now we have for each of our students, we have make a brief introduction and also introduce what is your final year project. So you new guys are final year project, U4, U3? Okay, U3, right? So please make a brief introduction about yourself and also let us know what you expect to learn from this course. For example, just now you mentioned, they want to learn the artificial intelligence, they want to learn something about the unmanned autonomous systems like drones. So let us know what you want to learn and brief introduce yourself. Okay, start from you.
My name is Wang Xuan, and I want to learn the user student A uh, maybe about the UAS. Yeah.
And also from year 3 AE, and then I want to learn about some trajectory path planning, like that. Yeah.
Maybe I can add a top of this course. Not top for master planning. Just usually in the coming weeks, each of the lecture, I will provide a top of after class task. For example, if the programming is Python for master planning or programming Python for plan, so start. So yeah, year 3, right?
Yeah, year 3.
My name is Huang Yichen from year 3 AE, and I want to study something about AI in US because I didn't study this before. I think about autonomous system. Yeah.
Okay. My name is Li Zhuohang, and I'm year 3 student and from AAE. I think it's Bing Wang. Okay. And my expectation for the class is, I'm also interested in the path plan, and I think AI is a crucial part of the trajectory plan, because in most of the using, I think for example, in the practical use of the path planning, we need the AI for the US to recognize, yeah, recognize the object, and so yeah, like that. Okay. Yeah. Yes. Yeah. Yes. Thank you.
My name is Liu Xiang. I'm from year Wang Bing Wang. Yes, and I want to learn about some intelligence, but not limited in engineering. Because we know that AI is a wide trend in the world, and I also have a part-time job in the company of UAS, so I want to learn about more.
Okay, thank you. So we only have several exchange students from NPU, they are U4. Okay, so the rest are all from U3. So those are the intended outcomes. And so for today's outline is going to be, not sure we can finish everything, okay? So what is AI and why we need the artificial intelligence, and roughly the history of the AI and the classification. So I think this is very important to provide the overview for you to understand what is the classification of the AI. Because you have, I mean, you have like maybe you learn a lot of terms like ChatGPT and the transformer and the Euro and maybe the gain. Okay, the cycle gain, a lot of new terms and how they are differentiate with HR. Okay, so how to understand all those terms. So the classification is very important. And the machine learning, deep learning, reinforced learning. So what is the differences in between them? And the blue parts, okay, the understanding of a ROS. So any of you have done a ROS before? ROS? Okay, 1, 2. Okay, from MP you have learned. Okay, oh, quite a lot. So the ROS is a robotics operation system. So this is, for example, if you want to learn the, like Louis, okay, if you want to learn LiDAR scan or the visual scan stuffs, ROS is the basics. You must learn the ROS. For example, like majority of the LiDAR scan pipelines, I mean open source pipelines, they are all based on the ROS. Almost 99%. For example, there are some open source pipelines that is non-ROS version. No one want to use it. No one want to use it. And okay, QA means any questions, BOA. Applications of the AI technologies for US. And for example, the common AI tools, frameworks, for example, like PyTorch, okay, and the TensorFlow, specific techniques and tasks, and the concepts for regressions, classification. So all those, today we are going to provide a quick overview of all those parts. But in the later on, in the coming weeks, we are going to dig into the theories, dig into the theories and applications. And the standard implementation process. For example, if you want to finish like the classification problems. So what is the basic or the general implementation process? So artificial intelligence. So this is the top 20, okay? Maybe tomorrow it's going to be changed, but at least today, let's see top 20. So for example, artificial intelligence can be applied in the e-commerce and education purpose, right? Your best friend, ChatGPT, and artificial intelligence in robotics. So especially for the humanoid robotics. So currently the humanoid robotics is quite hot. So because people thinking about, so the human robotics is very close to the human, okay? So this potentially can unlock the maximize the potential of the ChatGPT or maximize the potential of the large models, the world models. So if you feed all the data available since we have the worlds, so we can properly think the human robotics will be as intelligent as human and even exceed the intelligence of human beings. So this is the application of the AI for robotics. And for, okay, the first is for GPS, Sahat. Okay, so the first is for GPS. You're in the right track, okay? So the artificial intelligence and GPS and navigation stuffs. And artificial intelligence in healthcare. Okay, so this is a big topic. So I personally, I also very interested in the potential of, for example, if in the future, okay, so I just sitting here, okay, the camera take image on my face, it can tell you, so what, I mean, if you have eat dinner yesterday, everything can be, I mean, recovered based on this image with AI. And if you feel good or not good, and your all healthy parameters can be identified directly from AI together with the image of your face. This can be possible. This can be possible. So this is the potential applications of AI for healthcare. So automobiles, agriculture, and in human resources. Human resources means, okay, the AI will, okay, it will try to filter the resumes, okay, for the comments. And the lifestyle, social media, okay, of course, hog down like, uh, one of the good news, I will not say it's a good news. Do you know the red note? So TikTok is potentially be closed in US, right? So a lot of people, okay, get new account in the Reynolds. So let's see good examples for the social medias. So if you look into, the quick videos from the TikTok or from Reynolds, it will recommend a lot of similar videos for you. Okay, you lost the maybe one whole day. Okay, so this is based on the technologies behind is about the recommendations based on artificial intelligence. So this is one for examples of the AI for the social medias. And also for the gains, okay, trading bots, finance, data security, travel, transport, marketing, entertainment, and military. Okay, military. So AI is employing the massive applications. So for example, like Jones ChatGPT. So maybe your best friends I just mentioned, Jones, humanoid robotics, and the self-driving cars. So self-driving cars is quite close to our daily life already. So maybe in the coming 5 years, it's also in Hong Kong, we can see lots of self-driving cars. So this is a very famous test. It's called Turing test. Okay. So this is the intersection of the science fiction and the realities. So the question is, can machine think? Okay. So this is a test okay, defined by Turing, so the father of artificial intelligence. So the Turing test is originally called imitation game by Alan Turing. Okay. In 1949, this is a test of machine's ability. This is a test of the machine's ability to exhibit intelligent behavior. Okay, exhibit intelligent behaviors equivalent or indistinguishable, okay, from that of a human. So how it looks like, it's like this. So the A is for example, it's a machine with artificial intelligence, okay. So B is a human, okay. B is human. So the standard interpretation of the Turing test in which player C or C is humans, right? For example, this is me. Okay, there is a machine, there is a human. So I ask several questions to both the machine and humans. So the interrogator is given the task of trying to determine which player, A or B, is a computer. Okay, so for example, based on several communication or response between C and A, C and B. So to determine which player, A or B, is a computer or which is a human. So for example, this human C try to distinguish which is a computer and which is a laptop, which is a computer and which is a human, okay? So the integrator is limited to using the response to a written questions to make a determination. So if the human C cannot clearly or correctly distinguish which is machine, which is human, okay? It means this machine is intelligent enough and pass the Turing test. Pass the Turing test. But currently, if you use ChatGPT, of course, it can pass the Turing test, right? It's even much better than than a human. Okay, for example, take a undergraduate degree, take a bachelor degree. The ChatGPT is even better. Okay, and even in some of the specific research fields, the ChatGPT is even better for a doctor. Okay, for a PhD. For a PhD. So in 1949, okay, this is a very famous Turing test. Turing test. So for in terms of a category, okay, so this page is very important. So in general, in the top, on top, we have artificial intelligence. So this is a program that can sense, reason, and act and adapt. So in the middle, we have the machine learning. So especially in the 1990s or the 1980s, so researchers in US and in Canada are working, like Jim Hinton, they're working on the machine learning. So for example, the decision trees, support vector machines. So those are old and explainable tools or the techniques. Let's bring to the machine learning. So especially from 2010, okay, 2010, okay. So let's start to have the deep learnings, okay, deep learning, especially for the neural networks, okay, convolutional neural networks. So this is about deep learnings. So deep learnings is part of the machine learning. Or you can say this is a tools. Okay, this is one of the implementation tools of the deep learning. And deep learning is part of the AI. Oh, sorry, machine learning is part of the AI. So for example, we say deep learning, this is actually part of the machine learning. But usually today we say machine learning, usually this is going to referring to the old machine learnings, like decision trees and like random forest stuffs and support vector machines. So key features of the deep learning is this is a science, okay, devoted to making machines think and act as humans, like humans. So focus on enabling computers to perform tasks without explicit programming. And this is a subset of machine learning based on the artificial neural networks. So, and with more and deeper neural networks, more and more layers, and more convolution functionalities, and more stronger for the deep learnings. So in short, okay, so AI is on the top, machine learning is in the middle, okay? So the deep learning is like say different machine learning is a method of achieve AI. So deep learning is a technique for implementing machine learning. So it's clear? So in this course, okay, so we are going to talk about machine learning and also more focus on the deep learning, which is most popular techniques, especially for the deep neural networks. And on the top, we also still introduce some traditional or some old machine learning techniques. I mean, old means it's like maybe 20 years before or like 15 years before, 2006 something. So like decision trees, supported vector machines, and the random forest. So those machine learning techniques. So what is machine learning and what are two main categories of machine learning? What are some examples of machine learning and how does the machine learning works? So let's see very interesting definitions. I love this one. So machine learning is semi-automated. Semi-automated. So for example, currently the deep learning is right. Say it's kind of fully automated. For example, if you try with ChatGPT, right? So it's for almost fully automated. So machine learning is a semi-automated extraction of knowledge from data. So this data-driven deep learning learn from data and self-optimize. So for example, you see, so because probably you have buy the service from the OpenAI from ChatGPT, you see, at least in the several years before, maybe last year, it's the version of the ChatGPT. Okay, it's changed almost every month. Okay, so it means it will do the self-optimize because they train the model with new data, and even to refine or improve the networks models. So learn from data, self-optimize. It's called data-driven. So usually for the machine learning here usually means I'm talking about the old machine learning stuffs, okay? So good interpretabilities and intuitive and easier to understand. So easier to understand and good interpretability. This means it's not black box. It's not black box. So for example, we're talking about the deep learnings. Usually we will say, okay, so we get a good results. It's hard to explain. It's not explainable because it's a black box. But for the conventional machine learning, it's so that's why, especially in the even for today, you ask some old school researchers, they will still say, I don't believe deep learnings. Maybe this will take like 1%, okay, currently. Maybe 10 years before, they would say, I don't trust the AI. Let's maybe take about 20%. This number is decreasing, especially when we have the ChatGPT, okay. The number of people, let's say they don't trust on AI, is decreasing dramatically. So before, if we look into the machine learning, so old machine learning like decision trees, support vector machines, machines, everything is explainable. It's not black box. But currently the deep learning is black box. So this is a question, this is a problem. So for example, if you apply the artificial intelligence like deep learning networks to the drones, if the drones crash, okay, so how to identify? What's the reason behind for a crash? Okay, so this is problem. Still, it's a black box, but performance is good. It's exciting, especially for the large models. So anyway, for the conventional machine learning is provide good interpretabilities, intuitive and easy to understand, and also able to clearly demonstrate the impact of the features and prediction. So for example, like the classification problem with the decision tree, okay? So later we are going to introduce what is decision tree. So this is a conventional machine learning techniques. So if you input some features, it will output the classification results, right? So everything is like a white box. It's quite clear. It's explainable. Okay, so this is the key features of the conventional machine learning. So there are two categories. So usually it's, you may say it's three or maybe generally it's two. The first one is two category, okay, two main categories of machine learning. So the first one is the supervised learning. Supervised learning means you have the labels. You have the labels. So for example, every day you are enjoy the service or the benefits from AI to filter the spam emails. Otherwise, you will receive a lot of fake or spam emails. So for example, okay, so this is incoming emails. This is incoming emails. So first it will go through a spam filter. This is provided by Microsoft because all email service is from Microsoft. So this is an AI engine, okay? It will helps you to filter majority of the spam emails. So that's going to be mailed to your inbox. Okay, check. If you check your emails, you're going to see what is good email. And this is the mail trash. For the spam email, we go to this one, right? So for this, is the supervised learning because when you train a model, you have the labels. Another one is, so for example, when you train the models, you will tell, okay, which one you will label or training data sets. So which is the good email, which one is the spam email, or which one is a normal email, and which one is the spam email. So you have labels. Okay, you have ground truths. You have labels. So this means supervised learning. You have the labels. You know which one is correct, which one is incorrect. So it's clear. So for the supervised learning, okay, you get the labels. So for example, when you train the models, okay, you will tell the models in the data set, you will label which one is the healthy email, so which one is the spam emails. Okay, so we have labels. So this is machine. This is supervised learning. So another one is, for example, like segment grocery store shoppers into clusters that exhibit similar behaviors. So for example, this one is several clusters. For example, this is three clusters, right? I don't have the ground truth. I try to identify a boundary. I try to find out the boundaries between different clusters, and all the points in the given clusters have the similar features. For example, the colors, the blue, green, red. Okay, so those are the boundaries. But I don't have the labels for, okay, so which one is correct or which one is incorrect. No labels. So what I do is try to figure out the boundaries between different clusters. So this is called unsupervised learning. Okay, unsupervised learning. So for example, this is clustering. So it's clear? Okay, let me look into examples about the training of the email sparse, okay? So for example, okay, so this is examples. For example, if you want to train a model to classify the healthy email and the spam emails, okay? So how to train a model? So first, how to train a model? So first, you need to have a lot of data, right? A lot of data. For example, those data, I mean, different emails. Some of the emails are the spam emails, some of the emails are the healthy emails, right? So first, you need to have the data. So based on all those data, you can extract some features. Extract some features. Some, for example, in this email, there are some very weird, very strange symbols. So those are the features. Based on those features, you feed those features into the machine learning model. Feed those into the machine learning models. And also you need to have the labels. You need to label each email. For example, healthy email is 1, labeled with the number 1, and the spam email is labeled with the number 0, 0, 1, okay? So those are labels also feed to the machine learning model, and then train the model, then you get the models. So if you get those deep learning models, later on you can, okay, for the new incomers, for the new emails, for the new incoming emails, you can feed, extract the features and feed into the machine learning models and test the models with labels. Which means you can test, okay, if this email is healthy email or spam email. Okay, so this process is supervised learning. You train the models and test the models. Test the model means the practical implementations. For example, the daily filtering of the spam emails. So we have the labels, right? So this is just examples of the supervised learning. So for the one we mentioned previously, for this one, okay, this is a fleet of points, a series of points. I don't have the labels, but if I'm intuitive, if you look into those points, they have different colors, right? So potentially they can be divided into several clusters. So what I do is to try to figure out boundaries, okay, to divide those points into several clusters. So there's no labels, okay, no labels. So this is so-called unsupervised learning. Unsupervised learning. So another one is called the semi-supervised. So previously we have mentioned, so generally we mainly have the two categories. The first one is supervised learning, you have labels. Another one is unsupervised learning, so you don't have the labels, right? So if you, okay, for this one, okay, two parts, two different categories, right? So you can figure out this linear line to classify the two different categories, okay? So for example, this can be done by linear regressions. Later we are introduce this one. So linear regressions can be used to classify the two different categories, right? So very clear labels. So this is one category. This is another categories. So very clear boundaries. Okay. So this is supervised learning with labeled data. Okay, with labeled data. But for this one, okay, this is labeled data, and this is also labeled data for red pass, red dots, and blue dots. But for those, okay, triangular dots, we don't have any labels. Some of the data we have labels, some of the data we don't have labels. So this learning problems is called unsupervised, this is called semi-supervised learnings. Semi means supervised, within the middle of the supervised and unsupervised learning. Some of the data we have labels, some of the data we don't have the labels. So this is the semi-supervised. As I just mentioned, okay, so those black triangles are the unlabeled data. Unlabeled data. Okay, so in this case, we have three different categories. Okay, we have three different categories. So the first one is supervised learning with labels, and unsupervised learning, okay, without labels, and also the semi-supervised learning. So currently we are working quite a lot. For example, later we introduce the deep learnings, right? So deep learnings are mainly belong to the supervised learnings, okay, because we have the labels. So in here, okay, those are the conventional machine learning techniques, okay, like the k-nearest neighbors, like kn, and the regressions. So regressions, this is a good examples, okay. For example, regression align to distinguish the two categories: regression, linear regression, and line. And within the regression parts, we have three different categories: the logic regression, and the linear regression, and the multi-layer perception regression. So those are three different categories. So the linear regression is the most simple. I mean, the model is linear. And for this one, and the logistic regression is mainly to solve the, I mean, the nonlinear regression problems. And for the unsupervised learnings, mainly we have the k-means clustering. So clustering means to directly find the boundaries of the several different clusters. And the PCA is another solutions for the unsupervised learning. Okay, the green dots. Okay, the green path. The green path is what we want to focus in this course, the deep learning. Okay, so generally the deep learning always belongs to the supervised learning and represents the state of the art. Represents the state of the art. Yeah. So machine learning, three different categories. And unsupervised learning, we have the clustering and the PCA. So those algorithms are quite lightweight. Okay, lightweight can be implemented in short time period. And for the supervised learning, we have the KN regression. Okay, regression, we have the logistic regression and multi-layer perception regression. So the first and third is for the nonlinear case. Okay, later in the coming weeks, we will introduce all those theories in details. And the linear regression usually works on the linear problems, okay? For example, find a line, find a straight linear line to distinguish two different categories, So this is even more high-level classification of the artificial intelligence. So those are what we are going to focus on in this course. Also, one of the those two parts are the most popular parts. For machine learning, we have the linear regression, logistic regression, decision trees, random forest, Bayes trees, autoencoder, and SVM, KN. So those keywords. So especially for those, for example, in the 10 years before or like 15 years before. So those researchers, if they are working on machine learning, they are talking about the SVM and the decision tree, random forest. But 15, I mean, no. So if you are talking about deep learning, researchers in the machine learning or deep learning field, they are talking about again the IN, CN, and GPT-3, STM, and transformers. Okay, so those are the deep learning stuffs. And also in the within the boundaries, there are some other algorithms like genetic algorithms, but those parts are not as popular as those deep learning stuffs. Okay, as those deep learning stuffs. So in those long history, okay, so I'm not going to take all those one by one, but I want to figure out several key parts. So the first is 1950 or 1949, the Turing test. Okay, the Turing test. So the second one is Professor Fei Li. So Fei Li, anyone know who is Fei Li? Fei Li, Li Fei from Stanford University. Okay, originated from Sichuan province before. So this is the very important milestone. So Professor Li Fei generated data sets. So it's called ImageNet. So this is a big data set. Okay, so with labels. So they try to encourage the researchers from different universities and even industry-wise to do the classification of the image. So, and because if we have the data, so I think Professor Li Fei have invited even 10,000 workers to label the data. I cannot remember. I mean, Professor Li Fei is quite insightful. Even in 2009, so he spent a lot of money, maybe fund or money to invite a lot of people to label. Okay, to label, for example, in one image, to label which one is people, which is a cat, which is a desk, to label everything, and open source the data set with labels to encourage researchers to do the classification, to design the artificial intelligence algorithms to do the classification and the benchmark the accuracies. Benchmark the accuracies. And later on, okay, let's see one of the milestones with very crazy accuracies. And OpenAI, okay, OpenAI. So we have ChatGPTs and Meta. They also says what's transformer. Okay, so transformer is originally coming from Google. So because those researchers switch from one company to another company, they change a lot from Google, DeepMind, and OpenAI. So those are the several key milestones from Turing test and ImageNet and okay, let's Jane Hinton. So those from this year we have ChatGPTs and currently. So this is another milestone. In 2017, we have the transformers. So because currently the ChatGPT, the core parts is based on the transformer networks. And later on, we are going to let you know what is transformer. So those are the key milestones. So if you're interested, you can look into all those milestones one by one, okay? So how does the machine learning works? So the primary goal of the machine learning is to build a model that generalize. Generalize means, for example, if you train the model to to detect or to predict the spam emails, right? So you can only train the model with a given data set. So what you expect from the model is to generalize to the new coming emails. For example, I train a model today and I try to use this model to predict the quality of an email in the coming days. So try to generalize. So as I just mentioned, so this is the data. So extract the features, for example, so currently, for example, we have the deep learning, right? So deep learning can extract the features automatically. So previously, for example, if you use the machine learning, so you need to extract the features by yourself manually. For example, number of words from email, and if there are some spatial or very strange, weird symbols, and if there are some spatial words, so you need to extract features by yourself with the conventional machine learning. But currently, if you have deep learning, everything is just in one go. Okay, it can extract features by itself. So those are labels, but you need to provide labels and to train the models. So once the label is available, okay, you can just input those data to the feature vector and do the machine learning. Okay, do machine learning to test those models. So think about it. So if you use the conventional, because as I just mentioned, okay, so the university encourage us to implement the flipped classroom. So our students are encouraged to be included in this in this course, okay, in this lecture. So think about it. So what are the key features of the spam emails? So for example, if I use the conventional machine learning like the decision trees to classify, to detect, to predict the spam email. So what kind of features I need to extract? So what is the key features of the spam emails? What are the key features of spam emails? For example, I just mentioned several components. Okay, 2 minutes. Okay, search online to see if we are provide similar features. So if you use the conventional machine learning, below are some features. For this one. For example, like some very generic greetings, like dear users or dear customers. So I talking those parts are all about the conventional machine learning, okay? So if you are talking about the deep learning, they can directly extract the deep features automatically. So for example, like too good or to be true. So actually for me, I receive a lot of emails from some countries say they provide a big amount of money to me. So something like this, okay? Big amount of money. So those are the stranger rules. And some familiar sentence and no unsubscribe options. So those are the stuffs. And also, I mean, those can be part of the features. And if you're talking about conventional machine learning methods, they may deep into even extract some more deeper features. For example, in here I have 1, 2, 3, maybe 10 features. So for the conventional methods, they may even extract about 20 or 50 features. So those are the examples. So this is an example with conventional machine learning, the random forest. So random forest, the accuracy is about like 98% of the accuracy in the testing data set. So do you think 98 is a good accuracy? Of course, no. For example, every day you receive like 100 emails. You have 2 emails that is not predicted or filtered by the AI networks, by the deep learning models or by these models. This is not good at all. So the good accuracy for the spam email detection should be like 0.999 as the least this kind of accuracy. So for example, for me, every day, all the spam emails are correctly filtered in my email. So I say accuracy should be roughly reaching like 0.99939, yeah, the accuracy. 0.98 is not good enough. So because this is a random forest, so this is a conventional machine learning. Conventional machine learning. If you use the deep neural networks, the accuracy is going to be much higher and much higher. So this is an example, okay? So the hen and the spam emails are labeled manually to train the AI model, so the AI networks. So the AI model is used to classify the hen and spam emails daily. So that's why you actually every day you share the service already, okay? You benefit from the service already. And this is a quick look on the existing classifiers. So the first line is the names. So the nearest neighbors, the linear SVM, RBF SVM, the Gaussian process, the random forest, neural nets, edge boost, and the Navier Bayes. So those are different classifiers. Okay, the old machine learning, the traditional machine learning. If you're looking to those solutions, so those are the input data. So for example, the blue and the red, so this means two different categories, okay? So generally, they have a clear boundaries, okay? Something like this, right? They have clear boundaries. So this is the first solution, okay? The nearest labels. So this can be generally, okay, some of the points are not correctly, okay, predicted, okay, within the boundaries. And the second method is linear SVM. Okay, SVM means support vector machine. Okay, this is another solution for the conventional machine learning. So the classified accuracy is not good as well. Okay, because for those are not correctly classified. So for this one, okay, decision tree is good. Performs pretty good. Okay, the boundary is quite clear. Only 2 points are not correctly predicted. Okay. And for the add burst is also good. You see, okay, clearly found the boundaries, and this is the boundaries. And there's, okay, let's see different inputs. First, second, and third data sets, okay? The accuracy is quite different. So the first one is the regression for the So from this page, we are going to quickly go through the conventional machine learning methods. For example, the regressions from the linear regression, logistic regressions. So in the later weeks, okay, we are going to dip into the details. So it means it's okay from today if you cannot fully understand the equations. So later on, we are going to have the details for each of the machine learning methods. So if looking, if we go back to the problems of the classification of the spam and spam emails. So for the first one, it's the email data sets, and we train the models, and we can do the classifications. If we plot those spam and hand emails to this axis, okay, you can find the binaries. For example, if we use two features to classify the spam and the hand emails, okay, so they're going to be a binary between the two different categories, between two categories. So this can be achieved by the linear regressions. Linear regressions means try to find the straight line to divide to. We can use the linear regression to find the straight line to to distinguish or to classify the two different categories. So the linear regressions can be divided into two parts. The first is based on the numbers of variables. So for example, one-dimension cases is most simplified cases, right? One dimension. So for example, if you have multiple variables, that's going to be multivariate regressions for x1 to xn. So the f is the linear regression functions, okay? Multivariable from a single variable to multivariables. So and based on the function relationships, you can have the linear regressions and the nonlinear regressions. Linear regressions and nonlinear regressions. So for example, this one is the linear regressions, and for this one is the nonlinear parts, because for the variables we have the squares. Okay, we have the polytoons, we have squares. And another one is called logistic regressions. The function is slightly different. For example, we have the exponentials. We have exponential. So the function for this exponential function is going to be like this. It's going to be like this. So for example, okay, if this is the first time for me to learn, okay, what is logistic functions? Okay, I will ask ChatGPT. So let me show you how to make good use of the ChatGPT. Okay. Okay, for example, this function, okay, there is a exponential 1 plus exponential minus I, okay? So for the exponential function, so I will, okay. Okay, so this is the base code. So this is the base code. This is the enter for the end of unit. End of unit, the base code. Okay. Okay, so this is the enter to do the program is Python. So first I will ask the ChatGPT to okay, a lot of different versions, right? So for example, usually I think that usually on the website not to do it. The whole thing is not good. If they say, well, we generate from that, I'm going to the restaurant, you're not going to say, well, it's anything. For example, one again, for example, again, this line, so I don't have this one, schedule the creation one. If I have a time, I will also just be able to have a different one. So this is also component in the way capital or very clear here. So for generate the code, usually I use the Copilot or this one. Actually, for the simple coding with Python programming, the ChatGPT is good enough. Generate. You see, it's a generate. I think always. Okay, what's that? So okay, after you can create lots of functions. Just copy the code and copy here and if you run the code. Oh, this is just functions. Okay, you can see anything. Okay, so let's see what this function. So if you go back to okay, keep in mind, let's see logistic functions. So this is logistic function. If you have two factorial functions, okay, the function you can really okay distinguish with two factorial functions. So if you use a linear function to classify the function, okay. So for different problems, okay, you have different choices and different options. For linear regression, okay, you can leverage this function. So this is another case in something you want to do have a full and kind of give a control for the different items. Okay, with this regression, really follow the final. Okay, so later on we are going to, I mean, in the coming weeks we are going to let you know the details. So okay, so let's try the regression in 1 second. Let's try the regression in 1 second. Okay, so please, so let's be our laptop. Okay, another big and try it in the laptop. So after ChatGPT is generate, you have like generate the Python code for plot the logic regression environment. Okay. Okay, try this in your and this code is generated. This code is generated by the okay. But first you need to install this code. If you have installed this code, it's okay, please try directly. If you don't have, okay, you can see after ChatGPT and you can take a look at the code and make the idea demonstrate this one, okay? And from next week, we are going to introduce how to install the VS Code. Just enter and also install the Python task, okay? So okay, if you have VS Code in your laptop now, okay, try to take the code from ChatGPT and run it. If you don't have VS Code, okay, try it after you do this and get the code and try to read it. Okay, 10 minutes. Okay, so let's move on to the coming slide. So for this one, okay, let me try this again. So if I do this, copy this code. So have you any of you have replicate results in your laptop? Hands up. 1, 2, 3, 4. Okay, great. Have. So okay, so this is the promotes or the questions asked on ChatGPT and so generate the Python code, for plot differential functions. So see, okay, so this is the Python code. Okay, so for those who have learned Python before, you can roughly have a quick look on this. So import NumPy. NumPy is a library. Okay, this is a library for the numerical calculations, especially for the matrix calculations. So the matplotlib. So this is a toolbox for the protein figures. And the scaling is a machine learning toolbox in the Python. So this is open source. So I'm not sure if you have this experiences like 2 years before. So for example, for the PhD in the AAE, so in the AAE department, we only have several licenses for MATLAB. It's quite expensive, but because of the Python, so recently, okay, almost every student can have a license from MATLAB recently. This is because the Python is open sourcing, okay, make everything to be cheap and cheaper and cheaper. So Python is changing the world. So the first line is XY. So So this is the same. Okay, so this is the same. So let me copy this code to the VS Code. So VS Code is, as I just mentioned to you, so this is the editor. Okay, this is the editor. So on top, this is to include input. Okay, import some libraries. And from scalar linear model, logistic regression, and okay, scalar data set, import and make classification. So the first the line 7, so let's see to generate the data. Okay, generate to set data. So let me run the code first to let you know the our result slide. So this is the result. So if you run the codes, what you're going to get is, this is an example. Okay, it's very easy to learn, right? So this is one category. So this is another category. So the two categories is classified by the by logistic regressions. You can see a very clear boundaries in here, right? The yellow part and by this I would say non-yellow part. Okay, so this classification is based on regressions. Okay, you can replicate this demo with ChatGPT like in 7 minutes. But the bad news is at this moment, you know how to do this, but don't know what happened in the behind, right? So for example, if you want to know what is the accuracy for this classification, it's okay. You can manually look into, oh, the accuracy is like only 2 of the yellow points are misclassified. Accuracy may be like 98%, but this is not good enough. If you want to revise or improve the accuracy, you need to understand the mathematics and the principles behind. Okay, in this case, you need to know the details. So that's going to be introduced in the week 3. Okay, week 3 we're going to introduce what is the logistic regression and what is the mathematical models behind. You see, to solve this very simple classification problems, logistic regression is good enough. So this is the results. So let's go back to the codes. Oh, sorry, not this one. Okay, so for example, for the line 7, so make classification. So x, y is the output. So this function is to generate the two vector data, okay? Two vector data, x, y. And model logistic regression. So this is to define a model. So this model is based on the logistic regression. Model fit, based on the data, based on the model, we try to fit those data to get a regression, okay, get a regression. So finally, let's do plot result. This is to plot result. Plot means to make a figure to show results, x, y. So this is to define the features, for example, define the captions, okay, the labels, captions of the plots. Feature 1, feature 2, x, y, logistic regression, decision boundary. So those are all reflected in those, okay, feature 1 labels. Okay, feature 2 and let's do boundaries and logistic regression decision boundaries is this one. Okay, you see with the help of ChatGPT. Okay, I think this is a better way to really make use of the ChatGPT instead of helps you to only finish the reports. So at least this can help you to have a quick understanding what's going to be looks like and what's the generally, okay, the physical meanings behind. Okay, so for the mathematical principles, okay, it's going to be in week 3. So this is for this part. Okay, let me stop sharing. Okay, let me just share screen. Okay, so let's see the example we just mentioned to you. Okay, we can finish the question in minutes. And let's see the comparison of the linear regression and the logistic regression. So for a linear case, okay, so it's a straight line to like divide or to classify or distinguish to different categories. And for logistic regression, it's going to be generally, okay, the shape is slightly different, okay, based on the needs or the requirements for different problems. We may select a different. So linear regression attempts to draw a straight line. Let based minimize the residual sign of the squares between the observed response in the data set. So residual sign of squares. Okay, let's introduced in the week 3. So generally, it represents the distance between the point to the line because you want to find the best line fittings. And the response predicted by the linear approximations. Each type of the linear regression, it attempts to draw a line that best fit through a set of data points, so which is usually calculated using the least square methods. So if we have time in the week 5, we are going to introduce a little bit about the optimization methods. Okay, optimization methods for those regressions. So logistic regression is used to make predictions about the categorical variables versus continuous variables. So categorical variables can be true or false. It's going to be 1 and 0. Okay, so for linear regression, it's going to be a continuous, and for the regression, it's going to be, for logic regression, it's going to be 1 and 0. The unit or measure are also differs from the linear regression in that it produces probabilities, but the logic function converts the S-curve into a straight line. So later, okay, in week 3, we are going to explain this in detail. So linear regression is usually easier to understand, of course. The linear regression is very easier to understand because it's a straight line to distinguish two different categories. So linear regression also does not require a large sample size. So for example, the previous examples. Okay, this does not require the big sample size. Okay, does not require a big sample size. So the problem is like for the big models, for the big data samples, okay, the linear regressions may be not good enough. So without a large representative sample, the model may not have have enough statistical power to detect the significant effects, especially for large data samples. So this is another machine learning techniques. So this is called the decision tree. Okay, it's like a tree. It's based on a series of rules. Okay, a series of rules. So the goal of a decision tree is to create a model that predicts the values of a target variable by learning simple decision rules inferred from the data features. Okay, let's go back again. The goal is to create a model that predicts the values of a target variables. Okay, by learning simple decision rules. So decision rules means I have a rules, bigger or smaller, okay, should be or should not. So this is expandable rules, interpretable rules, okay? It's not black box, it's interpretable rules. And from the data features, so generally we have the root nodes, branch nodes, and the leaf nodes. So let's take a look on the 3 different nodes. So the first is A, the first layer. So for example, first layer A is the input. Okay, this is can be identified as the inputs. So the second layer, B, C, and D, it's based on different rules. Okay, we can go to B and G and D. So branch nodes. And last one is the leaf nodes. So leaf nodes is usually it's a resource. It's a resource. So for different branch, it's different rules. So for example, if A is a number, okay? If A is a number, it's 25, okay? So the decision tree is tries to figure out if this number is a number that's within 1 to 10. Okay, we can set up several rules. Okay, first we can like to check if this is larger than 0 or smaller than 0. It's a positive or negative variables. The nested rules. Okay, if this is the case, go to nested rules. If this is larger than 10 or smaller than 10, or it's larger than 20 or smaller than 30. Okay, step by step, check step by step. And all those are rules. Okay, so the result is goes from the leaf nodes. Okay, the leaf nodes is a result. Okay, also this will be interested in the week 3 and week 4. So each internal node represents a judgment. Okay, a judgment on the feature attributes, and each branch nodes represents the results of the judgments. Each leaf node represents the final decisions. Final decisions. Okay, the final decisions. Okay, so this is SVM. Okay, SVM is very famous, especially I mean when we don't have the deep learning stuffs. So the SVM is very generally it's very powerful. So especially compared with the decision trees is very powerful. So the concept of the SVM is like this is 2 set of data. Okay, okay, this is 2 category of data. This is 2 category of data. And each data, for example, this represented by X, for example, each data, okay, is a 2 dimension determined by x1 and x2, okay? So the x here is represented by x1, x2, okay, this is 1 point. A serial point, it means x1 is 2, and a serial point, okay? All the points are archived in this x. So x is the 2 by n vectors, right? Because each point is 2 dimension, n points. So this is 2 over n, 2 by n vectors, 2 by n matrix, right? So we try to find a hyperspace or the hyperplane to distinguish, okay, the 2 category of points. For example, if the point dimension is 2 dimension, it's a n by 2 or 2 by n matrix for x, right? So if the dimension is pretty large, like 100 dimensions, from x1 to x100, okay, for 1 point, it means x is going to be a 100 by n matrix, right? So in this case, the W is the parameters of the hyperplane. So for example, given a plane, how to determine a unique plane, okay? How to determine a unique plane? For example, for a 2-dimension, okay? How to determine a 2-dimension plane? Luis, how to determine a unique 2-dimension plane? For example, we need to have a non-vectors, right? Together with 1 point is good enough, right? So this is example. So for example, the non-vector. So this W is the non-vector of a hyperplane. This is a non-vector of the hyperplane. So the B plus minus B minus 1. Okay, this is the point. Okay, determine the uniqueness of the plane. So it means this plus this function. Okay, this is can determine the give a unique hyperplane. Okay, so this hyperplane can best distinguish the 2 category of points. So this is generally the principle of the support vector machine. So the essence of, the essential part for this is to how to determine the non-vectors. How to determine the non-vectors. The W, okay, the W is non-vectors of this hyperplane. So Wx plus B equals 0 is the separating hyperplane for linearly divisible data sets. For example, this data set, okay, 2 category of points, okay? So this is kind of very similar to the linear regression. So linear regression usually for 1-dimension cases, right? Or 2-dimension cases to regress, to find a line to fit the 2 category of points. But for the high dimension cases, the linear regression is not good enough. So the supporting vector machine is doing this, okay, take this job for the high dimension linear cases. So let me think about this again. So if you have a large scale data and for each of the point, the dimension is 100, okay? From x1 to x100, okay, this is a high dimension cases. Think about this. And we get a 100, for example, 1000 point. So the vector space is going to be 100 by n, and n is 1000, okay? A lot of points, right? So we try to figure out a hyperplane. So the non-vector of this hyperplane should be 100 degrees of freedom, right? Because you have 100 variables. So this hyperplane tries to distinguish, for example, 2 category of points. Okay, this is about the vector machine. And also you can do a similar things like to quickly replicate the demos. For example, as I just mentioned previously, you can, okay, after the class, okay, this is the off-class task. You can replicate the supported vector machine examples as well, okay? Just with Ask ChatGPT. You can replace this logistic regression to the SVM. It's good enough. You can quickly replicate this one. You can quickly replicate this one. So this is for the SVM. Okay, this is for the SVM. Okay, another one is the old. This can be kind of the old neural networks. It's called a multi-layer perception. So the name for the model feeds forward because let's only have the forward propagation. Feed forward artificial neural networks consisting of fully connected neurons with a nonlinear activation function organized by at least 3 layers. Okay, one by one, consisting of fully connected neurons. It means this one is fully connected with all the neurons in this layer. And for each circle, it's neurons. Okay, fully connected with a nonlinear activation function. So for the activation function, this will be introduced in the later weeks, organized in at least 1, 2, 3 layers. Okay, more layers means deeper. Deep learning means a lot of layers, okay? Deeper layers, a lot of layers, and 1 to 3 layers. and notable for being able to distinguish data that is not linearly separatable, okay? So this is generally a concept for the MAP, multi-layer perception. Another one is called clustering. So clustering algorithm is unsupervised learning. For example, in here, okay? So list no labels, but by doing the clustering, you can clearly find for different clusters, for this one, okay? Clustering algorithm is an unsupervised learning method for partitioning a data set into different classes or clusters according to the particular criteria. For example, distances. Okay, in the next week, okay, should be week 3, we are going to let you know how to do the clustering, okay, based on distance. For example, k nearest neighborhood clustering, okay, KNN clustering, okay, for example, this is for different clusters. So this is for the clustering. So the data objects within the same clusters are as similar as possible. You see, there's no labels. They try to find the base fit of the clusters to make sure the points within this cluster is as similar as possible. There's no labels, there's no ground truth. Okay, we try to make this cluster to be all the points within this cluster is quite similar, and all the points within this cluster is quite similar. It's quite similar. And K-means is one of the implementations of clustering. So it is based on the central-based clustering. So the basic principle is through an iterative process. For example, this is an iteration process. This is iteration. For example, like iteration 6, 8, 9. So finally, it will divide all those points into three categories, or into 3 categories. And the basic principle through an iterative process, the data points are divided into the clusters represented by the closest class. So for example, those yellow dots belongs to one clusters, and all those points within those clusters have the similar features. Okay, for example, similar shape or similar colors. And then the centers of the clusters are recalculated by the average of all the points. Okay, it's quite straightforward. Okay, by doing the average of all the points within the centers. So K means several parameters, the choice of numbers. So for do the K means clustering, you need to tell the algorithm how much clusters you're going to calculate. Okay, this is the number of the clusters and the distance measure. So usually it calculates the Euclidean distance, the square norm distance between the points to the centers. And the center of mass, each cluster has a center of mass, which is the mean of all data points within that cluster. So the center of mass represents the center of the cluster. And so this one is going to be optimization objective is going to be an iterative process. This is an example, okay? So from the top left, this is a K-means algorithm that's with 8 clusters. And the top right is divide all those points with 3 clusters. So actually, generally, if we divide all those points with more clusters, it's going to be more accurate, but it will increase the computation loads. Okay, and the top bottom left is bad initialization. For example, if you give a bad initialization, the iteration process will be like get into the local minimas. Okay, the result will become pretty weird, and this is ground truth. Okay, this is ground truth. So for example, this is the first clusters, second and third. And this is based on a bad initial guess. Okay, you're going to get some pretty weird points. And okay, this is one of the results with 8 clusters. So let's make a summary for what we have introduced. Okay, so far. Okay, so the first is linear regression. So linear regression is suitable for okay, with a linear boundary. Okay, the linear boundary can distinguish the two categories. So the second one is the logistic regressions. So this is the logistic functions, right? It's much better for comparing with the linear path, right? Comparing with the linear regression, okay? Because some of the paths are not, I mean, the boundary is not linear, okay? The logistic regression is a good option. So the decision tree is rule-based classification, rule-based, okay? So for example, as we mentioned, okay, this is first rule, so smaller than the minus 12, okay, smaller than 9, okay, rule-based, okay. So everything is quite clear. It's a white box, okay, no black box. And for the SVM, it's complex, especially for high dimensional linear regressions. And the k-means given no numbers of clusters and without labels. So this is SVM cases. And the upper part, the upper right, this is for the k-means clustering. Okay, so this is from support vector machine SVM. So any questions for this page for the conventional machine learning? Any questions? Flip classroom. More inclusion. Flip classroom. So in a so in a coming weeks, so please take your laptop. Okay, so for each of the algorithms, okay, I'm going to introduce the principles, and I will provide the example codes, and please replicate the example codes with your laptop. Okay. And one more after class task. So from next week, we are going to start with the 39 with deep learning and the deep learning and the GAN. And please try to replicate this one. Try to replicate this one in your laptop. You can use VS Code or you can use the Colab. Okay, you can use any platforms you can approach to replicate the Euro detection. So for example, in the next week, I will maybe like invite any of you to take photo for anywhere, okay? So for take photo for this or take photo for people. So make use of Euro to detection. Because Euro can detect almost all objects. People, desk, chair, or even the lamp or the projector. Okay, it can detect everything. So next week, please take your laptop. And before we start next week, please try this, okay? Try this in your laptop, So this is the after class task for you, okay? So in here, we also provide the code, okay? And one more thing I want to emphasize, is, you have seen the slide before? Have you seen the slide before? No? Yes? So it's really important. I think we need to maintain the integrity, okay? So the slide is, the slide is prepared by Dr. Ng. So the guidelines for the use of Gen AI. So as we know, ChatGPT is coming, so we need to really, learn from the state of the art, okay? So what I want to remind you is, especially when you prepare reports. So for example, in this course, we have a lab reports. So try to write the report yourself, okay? So you can learn from ChatGPT to generate code, generate a Python code, and you can revise and learn from the code, but please do not 100% coming from ChatGPT. So less strictly prohibited, it's not allowed, okay? Because for example, if your report is 100% coming from ChatGPT, a lot of tools can be used to check the similarities, okay, the AI similarities. Please do not do this. So because I really wish you to learn something from this course and have your own understanding, because your understanding should be able to be reflected in your lab report. Okay? Do you agree? At least you prepare lab reports and you prepare the codes, revise the codes. Of course, you know how to write and write something. what to write and what should be included in a lab reports. And so, okay, this is the importance of the digital literacy of the 21st century. Okay, later on, I will upload the slide to the Blackboard as well for your reference, okay? So understanding of the importance of originality and the guideline for students. So let's update it in April 2024. So guidelines respect your own work and the work of others. So for example, if you generate report from ChatGPT, so actually the report essentially, okay, essentially is also coming from the existing report, but they do some adjustment maybe. For example, let me raise the example. So like 1 year before, okay, I ever tried to use the ChatGPT to generate a code. It's about the GPS vector graph. Okay, okay, of course, ChatGPT tell me, okay, so this is example code. I find the code generated by ChatGPT is quite familiar to me. Okay, the definition of variable is quite familiar to me. And I look into the code again. I find the code is coming from my previous open source code. But I'm not sure today. Let me try again. I'm not sure today what it will tell you. What I want to say is ChatGPT tries to collect everything from website and reorganize it and provide to you. I'm not sure what it will provide to us again. For example, okay, let's see what I asked to ask ChatGPT like 1 year before, like generate the double plus codes for so the keyword is generate the double plus code. So in the range is kind of method is after validation. So it will offer tells you something. Ah, this year is different. It's different. Ah, let me add one more prompt. Based on self-sorrow. So this is the common provided application. Here very similar to my original thought. Very similar. But for this year it's slightly different. That different models variable rate becomes more concise. Yeah, it's still very similar to the open source code, to my previous open source code. For example, for this one. But the definition of variable is still much more concise. So what I want to say is, even you let your ChatGPT to generate more opportunity is also coming from the previous report. So just to organize all the information directly from that report. So this is guidelines. Okay, okay, let's see the example. For example, in the very last year, one for your senior, one for your senior students, prepare the final report, and find the assessor find the report, not on the not information can be find anything define but the feeling has to justify. They say, okay, I only get the technique to get me to editing, encourage the language. Okay, they need to provide some evidence. So later on, they provide evidence. For example, they have system policy from March, April, 11, every day. The college should is quite crazy. The college language everything. So they provide the country of the evidence. And yeah, this is as I just want to say to you, like if you can learn from trivia to generate code to help you to understand the equations. And even for example, if you learn some very technical equations in the class, for example, aerodynamics, so equations are abstract, not something that okay, you can have from calculating to calculate function, understand how it looks like. So it's also this abstract and practical. So what questions on so these two are more involvement in the course. For example, like you prefer everything live, no practice, no coding lecture, or just more practice. More or and object build no. Yeah, I will try to do more. And also Rick mentioned a plan, like I will try to include a plan as part here. I will try to work and take my hands on and take up doctor design. And that is why it also you have some practice all of the autonomous and then all the evaluation of things. I will try to provide some mechanical code for any idea. Yeah. Let's cover all the okay, so that's all for this lecture. Okay, so